Next we will be seeing the operations which can be performed on single linked list. As I have said before, we have three types of linked list: single linked list, circular linked list, and double linked list. Many operations can be done on data structures, and we know that most important of them are traversing, inserting, deleting, and copying, merging, and searching. These are the different algorithms that we are coming to see in the next sessions. So we'll go first for traversing. What do you mean by traversing? Traversing means you are visiting each and every node or every data element in a particular data structure. So as we know, we have a linked list here. Let's say you start with the header node, and in this example I'm taking 3 nodes. Let's say 41, 42, 43. Now I'm going to traverse this particular linked list. So what is happening? Suppose in traversing, as I just said before, we are visiting each and every node. Naturally, in programming style, we will be printing the elements. So first we have to print 41, then we have to print 42, then we have to print 43. Okay, so what will be the algorithm? How can the algorithm be? You have to start from the header node. Okay, the header node means in the header link part, you have the address of the first node, and naturally a variable that can hold the address is a pointer. So we start from the first node 41, and then you print 41, then you print 42, and you print 43. So this process of printing goes on until you find the null part or the stopping node. You know that the stopping node has the address part as null. So you go on printing, or you go on processing the nodes, or you go on traversing the linked list until you find the null part in the address. So this will be in a loop. So naturally we will be using a for loop or a while loop, and in most algorithms we will be using while loop. So let me check it out on an algorithm. As I have said, we should start with the header node. Header node means we are going for the link address in the header link part. So in the link part of the header node, you have the address of the first node. So header link part. Header link means the link part of the header node, and it contains the address of the first node, and I'm giving this address to a variable known as PTR. Naturally it will be a pointer variable. Now we have in algorithm a while loop. Why do we have a while loop? We have to check what is the condition in the while loop. PTR not equal to null. That means the address should not be null. Unless the address is null, you go to do something. What are you going to do? You are going to process PTR. That is, you are going to process that node. In this example, as I have said, traversing, we will be naturally printing the elements. So this process PTR statement, when you do programming, you can replace it with a print statement. Suppose you can give it as printf integer element. You can go to print PTR data. Okay, and that is meant by this process PTR. And next, what is the next statement? PTR is equal to PTR of link. PTR equal to PTR of link means now when this portion is a while loop goes on until the condition is satisfied. So what is the condition here? PTR is not equal to null. So when this loop stops, when PTR becomes null, this loop stops. So what is happening here for the incrementing statement is this: PTR is equal to PTR of link. That is, in first running of this loop, you have PTR as the address of the first node, right? Now you are giving this node's link part again to the variable PTR. Let's do it with an example. Suppose the address of the first node is 102. Address of this is 103. It not be sequential, let it be 203, and this is 300. Okay, So what happens here? When this loop is running for the first time, ptr has the value 1 or 2. Then you go to print 41. Okay. Now one more thing has to happen. ptr is having the value of ptr link. What is in the link part of 102? It will be 203. So that means now ptr will have a new value of 203, right? Now ptr will be pointing to the second node. Now this loop again continues since ptr is not null. What happens in the second running? Second running, ptr has the value 203, prints the value, second value, that is 42, and then ptr is incremented, that is 203's link part. 203's link part means 203's link part, it will containing the address of 300, so that is 300. Now ptr has the new value 300. Now does this stop while loop is not stopping here? No. Why? Because it is not, ptr value is not null. Now you go for printing the third value, that is 43. You print 43 and then again ptr is incremented. 43 is not 43, 300. 300's link part. What is the value? This is the value null. So ptr now has a value null. Now again it goes to the beginning of the loop. What happens here? Does the loop again enters? No, because here the value of ptr has become null. So what happens here? According to our algorithm, it starts from the header link part, that is address of the first node, and it goes to a loop. The loop means this loop continues until the value of ptr becomes null, and then it goes to processing the particular node. It may be a printing statement. Now the incrementing value is denoted as ptr is equal to ptr of link, that is the node, the present node's link part is given to the new value as ptr, and this process continues until the ptr has the value of null, and this goes the first algorithm of traversing. Next we will see the types of linked list. Mainly there are 3 types of linked list. Let's see it. For the first one is single linked list, next is the circular linked list, and the third one is the double linked list. I would like to give you a figure representation. Till now we have seen about single linked list, that is you have a single data part and the single link part, and this is our first category. Naturally you will have the header node here, which points to the first element n1, next element n2, and the third element n3. The second one, circular linked list. Diagrammatically, circular linked list is represented like this. What happens here? In single linked list, we have seen that this is the last element, and the last element has the address as null. But this cannot be found in circular linked list. In circular linked list, naturally you start from the header node, goes to the first node, next node, this is the n1, n2, and this is n3, and suppose this is the last node. The address of the last node has the address of the first node. That is, you have a circular manner here, and this is the importance of circular linked list. That is, the last node address, the link part of the last node has the address of the first node. Now next we have the third part, that is the double linked list. One of the beautiful linked lists is double linked list. You have one data part and 2 link part. One is known as left link and other is right link. This is the structure of a single node in a double linked list. You have the data part and you have the right link and the left link. And when you draw it as a linked list figure, you have the header node, the left link of the header node will be null, right link will contain the address of the first node, and first node, let me completely draw it and then I will explain. Now, this is the only thing we have non-till. Now, what is the importance of double linked list? In double linked list, you can go through both the ways. That is, you can traverse forward and as well as backward. So, how is the backward traversing possible? As I have said, we have the data part. Suppose 1, 2, 3. These are our data. Now, the first node, the left link of the first node will be pointing to the header link. The second node, left link of the second node will be pointing to the previous node, that is the first node. The third node, left link will be pointing to the second node. So what happens here is, as it can be defined, the left link holds the address of the previous node, right link holds the address of the next node. So this is clear from the figure. Now, the header node is pointing to the first node, and the first node left link will be pointing to the header node, and this can be seen. So pink color is used to denote the previous node and green color is used to denote the next node. So right link for next node, left link for previous node.